So we know from this equilateral triangle, each side was 2x, and because I cut it in half, it gave us that this little piece ended up becoming x. We're now going to focus on this right triangle here, and we're going to do Pythagorean theorem. We're going to say a squared plus b squared, which we're going to call h for height, is equal to c squared. Okay? A squared plus b squared is equal to c squared. Now, if I were to go and square these pieces, I would get 4x squared is equal to x squared plus h squared. And what is my goal? What is my goal? What is it that I'm trying to solve for right now? Anybody? H. I'm trying to find h, right? So what should I do? Subtract. Well, before the root, I'm going to combine like terms, and I'm going to subtract this x squared over, so that I have h squared is equal to 4 minus 1 is 3. 3x squared. Remember, there's an understood 1 right here in front of x squared. Okay? So I subtracted this piece from both sides to get h squared equals 3x squared. And now we'll do what Walter was saying as far as square rooting both sides to get h all by itself. What's the square root of x squared? X. What's the square root? So that's going to come out as x. What's the square root of 3? We don't have one, right? So the 3 is going to stay in. So here we go. This means the height that is opposite of 60 is going to be x root 3. That's where this piece came from. Okay? I'm going to show you how to use it in a minute, but that's where this came from. Now, let's see. This came from a square, half of a square. Can anyone tell me what this angle measure would be? The whole thing. 90, right? So, if I cut it right in half, just like Kaylee said, it's going to be 45 degrees right there. There's a lot of angles and side ratios for the rest of this unit pretty much, or the semester. So, we have a 45, 45, 90. And again, I want you to write / memorize this table. 45, 45, 90. And look at the picture. Here we go. Opposite from this 45, we have x. What do you think we would have opposite of that 45? X. And the goal is to see what would be the opposite of 90. Let's figure that out before I write it down right now, okay? So we're going to say, here's our work. We're going to say x squared plus x squared is equal to h for hypotenuse squared. Okay, so this time h, okay, is going to represent, the hypotenuse that I'm looking for right here. What's x squared plus x squared? 2x squared. How do I get h by itself? Square root. Can you take the square root of x squared? Yep, it comes out as x. Can you take the square root of 2? No. So h, the hypotenuse, is x root 2. And that's where that comes from. How many of you knew that before I just showed you? Okay, so that's where trig comes from, are those equilateral and the square. Okay, from those triangles. Now, let's use this information. There's a lot of real world application, guys. I mean it, a lot of real world application with the stuff that you're going to learn in this unit. Alright. Is this a special right triangle? Yes or no? Yes. What is it? It's a 30, 60, 90. So immediately, this is how I would want you to do your homework, okay? I would want you to first start off with writing 30, 60, 90, and then what would I want you to write below it? Or x root 3? Yeah. And then 2x. Cool. Now, do we know, or are we given any of those corresponding pieces? Let me show you what that looks like. Are we given a value that is opposite from this 90 degree? Yes. Yeah. So in the 90-degree column, we're going to put that value right there. A would be what?
5.
Okay, yeah, we're going to get there in just a bit, but here goes A right here, right? And then this is going to be B. The only one that has one variable that we can quickly solve for is this. And I'm going to quickly set up 2x is equal to 10 and solve for x as 5. Okay? And Jeremy is perfectly right as far as x being 5 means this. My goal was to solve what x is, because now I'm going to put 5 everywhere where I see an x. I already know it's going to give me 10 there, but ultimately if I put x as 5 here, I know A is equal to 5. What would B equal? If I put x is 5 over here, what would the value of B equal? 5 root 3. So 5 root 3 would be the answer there. Are we good? Okay, so let's do another one. Let's do this one right here. Is this a special right triangle, yes or no?
Yes.
Okay, what is it? Yep, 45, 45, 90, which I will write what underneath? X, X, and X root 2. Again, you have to have this memorized. This is how you start. I'm not going to have this written as far as like equations for you on your quizzes and whatnot. Okay, opposite from this first 45 we could say is B. Opposite from this second 45 we could say is 14. And opposite from 90 we're going to say is C. Which one can I do this kind of thing to? The second one. I could do that right here and set those two equal to each other and say everywhere where there's an x, I'm going to put a 14. Okay? So that means I'm going to grab a 14 and put it everywhere where I see an x so that these side ratios become 14, 14, and 14 root 2. So opposite from, here we go, in the 90 column, so that means opposite from 90, that length will equal 14 root 2. Okay? In the 45, it's going to be 14, and in the 45, it's going to be 14. So B would also be 14. Are there any questions? Okay? Here we go, bonus points. I'm going to pause the video, not stop it, but pause it. And I'm going to give you a good 4 minutes to work on these two problems. Please close your Google Classrooms because obviously you have access to the answers. And I want you to work out those together in groups, and we will go and grade them here in just a bit together. Go for it. Alright, so you did 3 and 4. Those are the answers. A should be 3 root 3. C should be 6 root 3. A should be, and B should be 8 root 2. Let me show you how you can do this if you did not get those answers. The first one was a 30, 60, 90. X, X root 3, 2x. This one was a 45, 45, 90. This is how I would expect you to do it on the quiz. X root 2. Okay, here we go. Opposite from 60 is 9. So this, if I set them equal to each other and solve for x, I would divide both sides by root 3 so that I would get this. What do I need to do to the denominator right now? I have to rationalize the denominator. I got to get rid of that square root. And the only way we can do that is multiplying by a form of 1. Here we go. This is my form of 1. Because you tell me, what is root 3 times root 3 equal? 3. And the top, what would that equal when I multiply 9 with root 3? 9 root 3. How does this reduce? Because reduction is huge as far as full credit for the semester, okay? Let's reduce everything. Can I cancel those 3's? No. But I can cancel the 9, right? With the 3 to make it 3 root 3. So guys, 3 root 3 is x. So everywhere where you see an x, I want you to write 3 root 3. What would this equal? 6 root 3. Nice job. And that's how you got the corresponding answers. Let's do the next one. Opposite from 90, we were given 16. Okay? So if I set those equal to each other like I did the last problem, and I solve for it, let's go ahead and do that real quick. I'm going to set up x root 2 is equal to 16. Divided by root 2. So 16 divided by root 2. What do I need to do? 3 words. Rationalize the denominator. Okay? So root 2, form of 1. Those multiply to give me what? 2. The top is 16 root 2. And if I cancel, reduce them, this would give me what? What's 16 root? It would be 8 root 2. So everywhere where you see an x in that little chart that we made together, over here, let me do it in green. Everywhere where you see an x, you're going to put 8 root 2. And sure enough, it will work. Okay? So it'll be 8 root 2, 8 root 2, and then it'd be 8 root 2 times this root 2. Guys, what is that equal that I circled? 16, which they've already given that to us. But I know the other ones will be 8 root 2, and they match up. Good? All right. So, let's keep going. That's just a quick joke about rationalizing the denominator and how you're lucky if you're taking math. All right, so let's go to trigonometric ratios for right triangles. So from the screen, what I hope that you should probably be thinking about is this right now. SOHCAHTOA. Those of you who are taking the ACT this year for admission or scholarships, or even next year, guys, this is a huge thing that people struggle with in my experience of when I'm tutoring them, of remembering what SOHCAHTOA is used for, when it's used for, and how it's used. All right. So the following trig ratios can be solved to solve the missing triangles, angles, or length of sides. Okay? If I asked you to tell me the sine of an angle, what angle could you find the sine for? Not 90. Okay? So, okay. Yes and no. Yes and no. This is the difficult part of second semester trig. Sometimes something will work, but you got to understand why and what context it's being used in. What we're doing right now will never take SOHCAHTOA, the sine, cosine, or tangent. We will never do that from the hypotenuses 90 degrees. Don't take it from there. It's only allowed in this context to be taken from these angles. Okay? So I could take the sine of A or I could take the sine of B. Okay, so sine of A and sine of angle B. Okay? What does sine even mean? It means the sine of some angle is equal to OH. The opposite, and that's what was shown on the video, over the hypotenuse. This is why we have SOHCAHTOA. Okay? Let's put our body. I'm going to do it, and let's pick red. We're going to put our body right here. So if I put my body right there, I can imagine with my hand, if you will, my right hand is 10. My left hand is 8. Okay? And this 6 way over here, it's none of my hands. This is like an opposite side. So from the video that we saw at the beginning of class, this is opposite from where I'm standing. This is hypotenuse from where I'm standing. And this is what? Adjacent. Guys, how can you tell the difference? Because a lot of people struggle with it. Between which one's hypotenuse or which one's adjacent. How do you tell? Hypotenuse is bigger, or hypotenuse is always across from what angle? 90 degrees. Okay? So, you tell me. I need a sine, otherwise an opposite over hypotenuse ratio from angle A. Okay? So what's the opposite side from angle A? 6. Good. What is the hypotenuse side length? 10. Would this be a fully acceptable answer? No, because we need to do what? We need to simplify. We need to reduce. What's 6/10 reduced? 3/5. There's your answer. Okay? Sine of B. I'm going to start calling on people, so be ready, okay? Sine of B means we're going to put our body now where B is at. Okay? So imagine your body is where B is at. Megan, what's the sine from B? What's the opposite over hypotenuse if you were right here at B? What's the opposite from there? 8. Yep. What's the hypotenuse from there? 10. So your reduced answer, Megan, would be what? 4/5. Good. So the sine of B is 4/5. Are we seeing the pattern? Okay. So now let's go over here. We're going to do cosine of A. Again, we can't do C because it's the hypotenuse 90-degree angle. We're going to do the cosine of B. Then we're going to do the tangent of A. And we're going to do the tangent of B. Let's go CJ. What's the cosine of A? First of all, tell me, CJ, what is the ratio that you're looking for cosine? Yep, adjacent over hypotenuse. CJ, what's the adjacent if your body is right here at A? Yep, and the hypotenuse? 20. So the reduced answer is? 3. No. Close. You could divide both of them by what? 2 and get 8 over 10. But then you could divide by 2 again, right? And get what? 4/5. Yeah, 4/5. So you could divide by 4 right off the bat, and it would reduce to 4/5. You'll see that? All right. Said, what's the cosine of B? Okay, cosine is adjacent over hypotenuse. Said, if your body is right here, what's adjacent if you're standing right there? No, that's opposite. See, if you're standing here, Said, opposite is 16. Adjacent is one that's right next to you that's not the hypotenuse. So, Said, what would it be? 12 over 20, which would reduce to what? Not 4. Oh, wait. 3 over 5. Because you're dividing both by 4. Okay, Gabe, let's go with tangent of A. Let me set you up. You're here at A. We know tangent is opposite over adjacent. So what is opposite from A? 15 over 20. Yep, which reduces to? Close. Help them out, someone. 3/4, yes, because you're going to divide both top and bottom by 5. Good. Brendan, what's the tangent of B? So 20 over 15, because it's the opposite over the adjacent. And anyone, what does this reduce to? 4 over 3. Cool. Alright, so now what we're going to do is we're going to do a little bit of practice with finding sides, first of all, with non-special right triangles. Why is this triangle not special? It's not 30, 60, 90, nor is it 45, 45, 90. So we're going to immediately go to SOHCAHTOA. True or false? True. When do you use SOHCAHTOA? Because there's all kinds of triangles, guys. There's scalene, there's right, there's obtuse, there's acute, isosceles, only right triangles. Only right triangles. Okay. So, to solve this, my goal is to set something up using SOHCAHTOA. What's step one? Let's go with Madison. What is step one? How would you approach this? Right here. The opposite and the hypotenuse, yes. So she's putting her body per se right here. Okay, so here's Madison, and opposite and hypotenuse. So we're looking for O and H, and the only one of these that has both of those letters is going to be sine. Okay? So we're going to get ready with the calculator. We're going to use the calculator here in just a bit. We're going to say the sine of 38 degrees is equal to 7.1 opposite over x hypotenuse. Some of you probably saw this in the video and you could recognize it. You might want to watch the video again if you need to. From what you see here, how can I solve for x?
You swap out sine and x.
You swap them out. You're going to flip-flop these two. Oops. You're going to flip-flop these two. And you can only do that because the x is down here all by itself. And there's only one term over here. Yes? Always from the angle. There it is. It's always looking at it from the angle. Okay? So it's going to be x is equal to 7.1 divided by sine of 38. Now here we go, guys. Pay close attention because we're about to use a calculator. And we have to make sure that first of all you understand. You're going to be in competition with my calculus classes when it comes to using these calculators because they're going to be upset with you because you're going to keep putting it in degree mode, possibly. And guess what they're going to do? They're going to keep putting it in radian mode, okay? So the default mode, guys, if you press, and I want you to do this with me, please, as we go through. You do need the calculator practice. Press Home, 2, Menu, C, and you press OK twice. Okay? And when you do that, you should have a clear page, and it defaults to the angle to become a radian. So if you press 1 and you press 1 again, right here on your default after a clearing will be radian mode. Okay? To change this, you have two options, okay? You can either change this to degree mode, which you have to learn how to do both, but then you choose an option of when and where you use it. Or you can, when you're doing your work over here, just make sure that you put degrees as far as a symbol in the angle. Okay? You have one or the other. I'm going to show you both. So let's keep it in radian mode for now. Let's go back to our notes. And we're going to solve this by putting it into the calculator. Here we go. So you're going to do control divide 7.1 over the sine of 38 degrees. Okay, so the sine is right here where trig is. The sine 38. And find the pi button, guys. The pi button is on the bottom left. And I will continue to train you with these calculators throughout this entire semester. The pi button is on the left. You're going to click on the degree symbol. And now this will give you the answer. How many decimal places do you think I want you using unless otherwise specified for this entire semester? 3. 3 decimals, okay? So how do I get 3 decimals if it only shows 1? Go up. Go up, press enter, and it'll pop everything up. So I want you to do 3 decimal places, so it'll be 11.532.
So what does it mean in degree mode?
Okay, so here we go. So in degree mode, if I did control clear, if I did home, follow me please, because you got to know how to do this, because you will use this at times. Press home. 5, 2. And this angle needs to change to degrees and make it your default here at the very bottom. Click on that Make Default. I'll do it again. 5, 2. Make sure this is on degrees. And then scroll all the way up or down until you get to Make Default. And press OK twice. Now look, press 4 for your current document. Okay? Now here we go. If I go up here, it means that I don't have to put this degree because all numbers inside of those angles, like the parentheses, will always be interpreted as degrees. So whenever I press Control Enter, I get my same answer. Okay? This will make a lot more sense. He asked the question a little early, but this will make a lot more sense here in a couple of problems when we start doing things backwards. Yeah?
Do we have to press the sign to get to the sign? Press trig to get the sign.
Yeah. So the trig button will do all of the sine, inverse sine, cosine, inverse of cosine, so on and so
Can
forth.
we just type it in?
You can type it in as well.
Okay.
But when we start doing these right here, Diego, it's best not to type them in. It's best to use that trig button. Okay? So let's go back. So, and that's the thing. To see what he's asking, to me, I don't like to change it back and forth over and over and over again. Because sometimes I forget to make it my default, and it's still in the wrong mode, and I will get the wrong answer. Okay? So physics is done in degrees. Okay? Calculus is done in radians. We had some physics people years back when they took their AP exam. When they clear these calculators, it defaults to what? Radian. So all their calculations were wrong because they were in the wrong mode. So it messed them all up when it came to their AP exam because they forgot to put it in degree mode. Okay? That's why we teach people, don't get dependent on the degree mode. Learn how to use this degree symbol right here where the pi is at. Right here. Use this degree symbol and you won't run into that problem and you don't have to worry about that.
You still use the degree sign.
Yeah, it just overkills it, but nothing changes. It doesn't offset it. Okay? Alright, so let's go to the next one. We have 50, we have 35, we have x. Okay? Step 1. Eric was asking it earlier. Step 1. What should I do when I look at these problems? Step 1.
Look from the angle.
Look from the angle. So let's put our body and pretend we're standing right here at A. X and 35. What's x? Adjacent. What's 35? Hypotenuse. What has those two letters with SOHCAHTOA? Cosine, right? Cosine. So COH, so it's going to be the cosine of 50 degrees is equal to x over 35. What can I do to solve for x, guys? Go ahead and say it. What can I do to get x by itself? Multiply both sides by 35, right? Check this out. I know it's been a while. Let's see if you remember. You can multiply it by 35, or if you're new to this class, you do want to be paying attention right now for sure, you can do menu 3-1. Okay? Menu 3-1 will solve this for you. And learning how to use the calculator is good. It's not a cheating tool. It's not because you still have to learn the math anyway. So I want to put this into my calculator exactly the way it is on my paper. The cosine of 50 degrees. Do I need to put degrees, yes or no? Right now, from what you see. No, because it's in degree mode. Is equal to what? Control divide x over what? 35. Guys, what am I needing to tell it to solve for? X. So, some of you already know this from last semester. Whatever you're telling it to solve for, you need to put comma and then that variable. All of this other stuff is exactly the way it looks on your paper, nice and pretty, and you're just telling it what to solve for. So that when you press Control Enter, it gives you this. Almost correct answer. We need it to be 422 point what? 497 or 498 if you want to round. Okay? Either one is fine by me. So can someone say that again out loud, please?
22,498.
Perfect. All right. Any questions so far? Okay. I'm going to do one more example, then I'm going to let you do 3 alone. Okay, let's do one example together. So don't work ahead, please don't work ahead. I need you to watch this next one, okay? This next one is different. I'm now trying to find the missing angle. See, I've been given the angles all day. Now I'm going to work backwards and find the angle. Okay? I'm trying to find this angle right here. What 2 sides do I know? Hypotenuse and what else? Opposite. What trigonometric function am I going to be working with? Sine. So, sine. So, I'm going to put sine of some angle. Let's put theta. I want you to get used to theta. This is for angles. The sine of some angle. This is like if you were to put sine of x. It's an unknown. It's a variable. Is equal to what? 11.8 over 13.5. Now look, guys, you know the calculator. Could you put this into your calculator like solve and put theta? The answer is yes, but look, it's going to glitch out sometimes. You're going to learn some crazy stuff that this can do and what it represents. When I am using the solve feature, I implore you and I almost beg you, if you're going to use this, don't use just solve, use in solve. Okay? Let me show you how you can get that with a calculator. You can press from here, menu 3-6, menu 3-6, or you could just press down here the letter N and then menu 3-1. Whatever you want to do. Okay? Now let's go ahead and put this. We're going to do, what did we say it was? The sine of theta. So the sine, and look up here because you're going to need to know where theta is at. It's the pi button. Scroll over and then close that parentheses and say it's equal to the 11.8 over 13.5. Whoops. That was weird. 11.8 over 13.5. What do I need to do now? Comma, not x, but comma theta. So comma theta. And now look at that pretty answer. Now look, if you had not done in solve, okay? This is very important what I'm showing you right now, okay? This is where all the simple errors come from that I want you to see from this rather than you experience them yourself. If I put solve, look what happens to the answer. What is that? Okay? You will learn what this represents later, but right now this is crazy. This is going to scare people away. So if you get an answer like that, my best suggestion is do this. Look up here. Press N, go up, grab it, and try it again. And there's my answer. Okay, what?
I got a different answer.
Okay, so he might have gotten a different answer. I'm almost willing to bet money because he is probably in what mode? Radian mode.
Just put the degree on the theta.
Okay, so here's what you need to do. You can't put the degree, this is a good mistake, and I'm giving him participation points for bringing this up. Just because you're looking for a degree doesn't mean that you put a degree here for theta and it will spit out a degree. You'll learn what you need to do later for that. So my biggest advice to you is, if you are looking for an angle, put it in degree mode for now. If you're going forward, that's kind of going backwards, trying to find the angle. But if you're going forward like the first couple of problems, you can put the degree symbol in it. But if you're going backwards and you're trying to find this angle, I would prefer you to use it in degree mode. Now look, last thing that I'm going to show you, then I'll let you do this last problems. We're almost done. We have a couple more things. Can someone read that to me? Anyone, go ahead. Sine of theta. Sine of theta. In math, 9 out of 10 times. What do we do when we hear the word of? We multiply. Parentheses. Do you think multiplication is occurring here where I said sine of theta? It's not. That's the number one mistake people make. Even though they know the trig, they don't know the basic algebra part of the trig. That's not sine times theta. Okay? This is very, very important. That's not sine times theta. You tell me, how do I get rid of this squared? Is that x times 2? No. You're going to do something called the inverse of. Remember this? It cancels it out to a form of what? 1. Or in this case, x, right? What if it says square root of x? Tell me, how can I cancel or get rid of this? Squaring it. You with me? You're doing, they're called inverse operations. The inverse operation to cancel the way this is canceling, not dividing to a form of 1 or multiplying to a form of 1, but undoing to a form of 1, is to apply the inverse of sine, or the inverse sign to both sides. The best way I like to say it is called the arc sign. So the arc sign of this, these cancel, and I'm left with theta. And now you're going to see what Diego was saying earlier. As far as which ones, can you just write them down? I prefer you to use the trig menu, because now we're going to look for this. You with me? Alright, so let's go to that real quick for practice. I didn't have to do the solve feature. I could, and you have to know this because some of these multiple choice questions may or may not have this stuff that you're going to have to get used to. The arc sign of control divide 11.8. Did it again. What's the? So 11.8 over 13.5. And you'll get the same answer. I'm not giving you options. I'm not teaching you this and saying, hey, just choose one and do it. Like I'm showing you because you got to know them all. Okay? Whatever ones you need to use, when you need to use, you develop that through practice and homework. Alright, so now let's go ahead. Because of the sake of time, I wanted to give you these for points to do with your team. But for the sake of time, I'll just let you fill that out. Because we didn't have enough time. This is a good thing about Fifth Classroom. We don't run out of time. We have an ample amount of time to do practice problems together. Okay? Because you have to watch the videos and learn it preemptively at home. So this I'll let you fill in later because I need to make sure that you understand the difference. And there's the answers right there. I need you to know the difference between, that's just a joke about talking about degrees and radian modes. Make sure that you understand which one's which. You need to know the difference between angle of depression and angle of elevation. Alright, here we go. Right triangle. Orange angle, blue angle. And let's say green angle. Is the blue angle of elevation, angle of depression, or neither? Look at the blue angle. Is it angle of elevation, angle of depression, or neither? Angle of elevation. Okay? And a good way to know that, guys, is that this angle of elevation is coming upward from a horizontal line. Okay? So if you're thinking about a horizontal line, so from here, it's going upward. Okay? So let me make a quick copy of that, if it lets me. So from there, oh, that was the triangle. It's just going to make an upward elevation to where here is now my second. Okay? An angle of depression, you tell me. The green, is it angle of depression, angle of elevation, or neither? Neither. How about the orange? Is it angle of depression, angle of elevation, or neither? It's actually neither. The angle of depression is not where the orange is at. They come from horizontal lines. If I go up, there's the angle of elevation. If I go down, this is the angle of depression. So on ACT questions, a lot of times they'll say a triangle with an angle of depression of 30 degrees. People do this. That's not 30. The angle of depression is 30 here. What angle would this be? 60, because it comes from a 90. So when it's an angle of depression, it's the same. It's synonymous, similar to angle of elevation. So if you hear an angle of depression is 30, or an angle of elevation is 30, it's safe just to put that here. Do you understand? Who can tell me that you learned in past math of why these two are the same from what we're talking about right now? Say again? Parallel lines, yeah. So the parallel lines that stem to, you might have probably were about to say it. Yes, parallel lines with a transversal. These are called opposite interior angles, and they're equal. You with me? Okay, so let's quick review on this because this is important. 1, 2, 3, 4, 5, 6, 7, 8. 1 plus 2 equals what? 180. 1 plus 3 equals what? 180. 1 and 4 are what? No, 1 and 4 are equal. They're vertical. Vertical angles. You with me? How about 1 and 8? What are 1 and 8? Alternate exterior, but they're equal, or are they 180? They're equal. So 1 and 8 are equal. Okay? 1 is an obtuse or acute angle. Obtuse. Guys, look at this. If I have an obtuse angle and another obtuse angle, my only choice is this. So this will either be 2 acute angles or 2 obtuse angles. Do you agree? Where the shortcut visually for you visual learners is the acute and the obtuse will always be 180. 2 and 5 equal or 180? 180. How about 2 and 6? Equal. They're called corresponding angles. Just a little bit of review. Let's go to this. What is the description of the angle if it relates to the situation? You have 1, 2, 3, and 4, guys. You tell me, what's angle 1? Angle of what? Angle of depression. Okay? Angle of depression for 1 because it's coming downward, like down from a horizontal.
Do we have that?
Yeah, it should have. It's the last sheet back there. Yeah, it looks like this. If you don't have it, get it before you leave, okay?
Yeah.
There should be.
No, we don't have a picture of this.
Oh, my bad, my bad. Okay, so just look up here. Okay, my bad. What other? What is number 2? Angle of elevation. And number 3? Angle of depression. Number 4? Angle of elevation. All right, cool. This will tell you at least when you read, you're going to do a lot of reading problems, guys. You're going to do a lot of word problems this semester. You got to know how to read to set up so the pictures are being able to be computed or calculated very easily. Okay? That's pretty much it that I have for you guys because the rest is in your notes. Now look, I'm going to record this so that you can hear it. You will have a homework due next time. You already picked up the homework. It's due at the end of the period next time. Here's another thing. I'm going to post the videos online tonight so that you can get a good start on the things that we're going to be working on Thursday. So I have another stack of papers. And those papers are for what? Thursday's class. I want you to pick that up on your way home, or on your way out of class today, okay? On your way out of class, I want you to pick up those, keep them separate, and know these are going to be for day 2. Okay? It is going to be very well organized, I promise you, in Google Classroom. Just make sure you stay organized with all your stuff out there. Okay? We will have a quiz not on Friday, but on Tuesday of next week.